Okay, did we talk about how to use the add subtract rule to get to the blue line? Okay. The add subtract rule is actually, in my opinion, the most intuitive, meaning the rule is kind of what you would guess the rule would be. It's really simple. When I have ddx of 2 or 3 or 4 or whatever terms being added, I can use the add subtract rule to take one large ddx operation and create two smaller ones. So it just breaks across the addition or subtraction sign. So from here to here. Notice how this part doesn't change at all. Also notice that you have 1, 2, 3 factors being multiplied. So on the very next line, you still have to have 1, 2, 3 factors being multiplied. That's why you must have this parenthesis and this parenthesis. Laurel, please.
So from the green, it says 2 parentheses 3x to the 4th minus 5, and that has the 2 minus 1. Where did that go?
Gotcha, no worries. 2 points, 3 points actually. So I wrote 2 minus 1 to emphasize that I'm using the power rule and I've got to take the n minus 1. And then I noticed that 2 subtract 1 is just 1, so I just don't have to write it. That's all. There you go. Please.
So the n is, because of the power rule, the n is the x.
So up here, the n is 2. That's the power rule.
Oh, okay.
So in the very next line, when I do the transformation from this half of the power rule to this half, that's where the 2 here comes from.
Okay.
Is that what you meant? 2 points? It's unfortunate the exponent wasn't 7. I could have given Greta 7 points, but you know, so never mind. All right.
What have been said?
We good? Any questions on the blue? Awesome. Okay, just a reminder. Make sure you write exactly what I write.
This is for Jim's plan.
James? Thank you, Mom.
Thank you.
Make sure you write what I write. It won't take very long before you will just start asking, you'll start raising your hand and you'll say, hey, do I really have to write this line? And with a little bit of practice, I'll be able to tell you, no, you don't. But if you start skipping lines too soon, you get really confused and I can't help you. In fact, I won't help you. So for now, just write everything. Trust me, I am more excited than you are to get to the point where I don't have to write so much, because I do it every single period. So, good to hear. Next step, we now have a ddx operator on this. One common mistake is to think that you use the power rule here, but you cannot use the power rule here. Raise your hand if you know why you can't. Like, why would the power rule not be valid for this piece? I'll get everyone you know. The hint, the power rule says you have ddx of some expression to a power. So if we're using the power rule, this must be ddx of some expression to a power. So why is the power rule not valid? It would be illegal. So what's wrong with trying to use the power rule, Jack?
Because power 4 doesn't apply to 3.
Perfect. The exponent of the 4 is only a power for x. It's not a power for the 3. The power rule says I've got to have something to a power. What we really have is a multiplier, then times something to a power. How many saw it? 2 points, 3 for Jack. Questions? That's a common error. So instead of using the power rule, I'm going to use this multiplying constant rule, which is used anytime you have any constant. A is just any constant multiplied by any expression. The constant simply comes out of the derivative operator. So now I have this. This part again, you just keep writing. Questions? I haven't written the D of 5 yet. I have a comment about that. So. Okay, let's talk about D of 5 for a minute. Points for the whole room. Raise your hand. What does the small d stand for? It has to be a small d, by the way. Don't invent your own notation and use capital D. What does the small d stand for, Bryn? Difference. Infinitesimal difference. Oh, you knew it? 2 points, 3 for Bryn. So small d is infinitesimal difference. Well, look. If I have this, d of, make sense of this, it'll make it easy to remember. If I have d of x cubed over dx, depending on the value of x, this changes. Like if x is 1, this has a value of 1. If x is 2, 2 cubed is 8. Okay? So any change in x will cause this to have a different value. Hence, there is a difference in the values. And this process is finding that difference. 5. 5 is always 5. So there never is any difference between 5 and another 5. There's always 5. So when you see derivative of a constant, I don't have this as a rule on your green sheet. If you want to add it, you can. The rule would basically say that if you have the derivative, so you have d dx of any constant, anything, just a for any constant, the result is 0. Constant isn't changing. So the derivative means find the rate of change. Well, the rate of change of 5 is 0. This 5 will always be 5. Question. So that means here I can just write subtract 0. Because the rate of change of 5 is just 0. Question. Please.
How does d of a correspond with d of 5?
Oh, so the a is just my symbol for any constant. So a could be 6, 10, -2, pi, e, whatever. None of those constants are changing, therefore the rate of change of any constant is 0. Super Luke? Maya, please.
So it has to be over here of x times 0.
It does. Because we'll eventually see this in the future, just d of x by itself, which just means small difference in x, small change in x. But for now, we're always trying to find a rate. And rate is always a ratio. So it's always change in y divided by change in x. 2 points. Anyone else? Cool, next thing. So we're good to there. So the next line, f prime. There's my 3. Raise your hand. What rule do I need to use here? So I've got to do something with this dx to the 4th over dx. So you have to find a rule on the rule sheet that matches. And what you're looking for is the left side of each rule. One of these rules on the left side will look just like this. D of x to the 4th over dx. So hands up. What rule is it? What rule fits? And? Somebody knows? If you're struggling, you're probably overthinking it. When I look at power, all I see is some expression to a number. When I look at ln, it's just ln of some expression. When I look at sine, it's sine of some expression. So I'm trying to figure out, I have d dx of this, which one of those does it fit? And okay, everybody? So what's that?
The multiplying rule,
Just tell me why.
because you have
Oh,
dx on the bottom and then multiplying on top.
So 3 points. Let's talk through it a little bit more. So definitely dx on the bottom. I definitely have the d here. So now we're comparing.
Constant of 3 for a.
Oh, good question. 4 points. The constant's already been moved. So we've used this rule. So we use the multiplying constant rule, we'll just say MC here, to get from here to here. So we've already pulled the 3 out of the derivative operator. So this does look like this. But the way we use these rules is always identifying this and then becoming this. So I want to look to see if this right here looks like this. And if it does, I have to be able to identify, okay, so what's the function in this case? Well, that would be like x to the 4th. The a would be 1. So that would fit, but if a is 1, this doesn't really help. So we don't really want to use this rule. Other choices? Let's go to Katie.
Is it the power?
So if it's the power rule, let's just check it. So we've got the d, we've got the dx. So we've got to have some expression to a power. So what would be the expression, Kate?
X to the 4th.
So the expression is actually just the x,
Oh, just X.
and then the n is the 4.
Yeah.
No worries, that makes sense. How many knew it? 2 points, 3 for Kate. So we use the power rule. That means we have to write this piece. So the n is 4. That's this n. And I have g of x. That's the x. New exponent. Then I have d over dx of the g of x. Like that. Question? Please.
So, the expression, so when we found out that it was the power rule that we had to use, isn't it like how you were saying, like the expression dx, it's not the full expression being raised to a power, it's just the x being raised to a power? But then it did work, so that's why it didn't work, but then it did work to change it to the power rule the second time?
I think I know what you're saying, but if I'm wrong, just keep asking me. So I think what you're pointing out is that here, I said the power rule doesn't work because the only thing being raised to the 4th is x. So I have to do something with the 3.
Yeah.
So I use the multiplying constant rule to move the 3 out of the d dx operator. This isn't d times x to the 4th. It literally means difference of x to the 4th, like an infinitesimal difference. So you don't need to pay attention to the d. The d dx is the operator. So here we have d over dx, that's the operator. And then our g of x is just x alone. And then the power is 4. Is that your question?
Yeah.
Okay, 3 points. Luke?
What is the thing of the dx over the dx?
So,
It's just the difference of, because the x is the same as the g of x on this thing?
yeah, in the rules, g of x is just a placeholder. It's just saying, as you use these rules, you're going to encounter all kinds of different situations where g of x could be pretty much anything. In this example, happens to be x. 2 points?
So in every question that we're given, are we going to be going from different, like using a lot of different ones?
Uh-huh. Yeah, the most common, I would say typically, you'll end up using about 4 different rules. And each problem is different only in which rule gets used first. And it's just a matter of applying the rule. So what happens is this, Cassidy. The first rule I had to apply was the power rule. When I apply that rule, it's essentially taking care of just this little part right here, the power. And I end up with all of this. Now I've got to take care of what was inside. So now I'm doing a derivative problem within a derivative problem. So I'm doing this piece. Well, the add-subtract rule broke this into two separate problems. So I'm still doing a problem within a problem, but it's getting smaller and smaller. Because now I'm just working on this piece and this piece. This part, that's 0, done. This piece, I use the multiplying constant rule, pull out the 3. Next line, can use the power rule. So that was from here to here. Did that answer your question?
Yeah.
3 points. Anybody else? Cool. D means difference. So this is the difference in x divided by the difference in x, the infinitesimal difference. Well, something divided by itself is always 1, unless you have 0 divided by 0. But since x can always change, this difference on an infinitesimal level will never be 0. It will be very, very small, but it won't be 0. So this is 1. 1 times whatever is just whatever. So now I have this expression. F prime is equal to I can multiply those two together now. That'd be 12. Like that. And if you choose, when you have 1, 2, 3, 4 factors, so I guess I have really 1, 2, 3, 4 different factors. You can multiply any of the factors if you want. So the 2 and the 12 can multiply to become 24. And it's somewhat traditional to move the x cubed over here. So now I have, remember, this was a formula for finding every xy pair of that. This is a formula for finding every tangent slope or rate of change of that. This is found using the rules, but essentially the rules do this. They, in a mathematical way, are finding a secant to the right, secant to the left, making the secants very short, and you get this kind of an image. At least for me, it's a good mental image. The idea that if I could zoom in a lot, I would see something like this. And then I can determine the actual slope or rate of change at one point. So, please, Brett.
So if we actually started plugging in x's, we would just get a graph of f prime.
Uh-huh. Perfect. In fact, if you think of Unit 1, they would give you problems, right, where they'd say, here's a graph of f, here's a graph of f prime. We just never talked about where f prime comes from.
So that's the answer to 46.
So the answer to 46 is this, because they're asking you to find f prime. Perfect. 2 for breakfast, 2 for lunch.
How come you didn't distribute the 2?
Oh, good. Listen to Bella, please. Everybody, 3 points for this one. It is totally legal to distribute. And then we could distribute this again, or what, that's totally fine. I have found, however, that in this class, it's usually not helpful. So I don't. And they don't require it, so there's no reason to. So. Good question. Please, say.
How do you know once you're done? Like, how do you know?
Points for Maya and Sadie. 2 points each. It was a team effort. The DDX operator, so watch the pattern, Sage. The DDX operator here is operating on in all of that. When you use the power rule, you basically just took care of the square. But notice here there's no DDX operator, so that part is done. This just gets rewritten, 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 rewritten. Nothing's happening. As we keep using the rules, the DDX operator just keeps working its way through each little piece. Eventually, there is no DDX operator. You're done. That's how you know. Does that make sense?
How did the 0 become a 1?
The 0 here?
Yeah.
It didn't. 2 points though. This is 0. Get at that. So I have subtract 0. So in the very next line, I just didn't worry about subtracting 0 anymore. When I applied the power rule here, the 4 is here. Here's the x, here's the new exponent. Then the last part of the power rule says I've got to take d dx of the x. So the dx over dx came from using the power rule, not from the 0. You see it?
Yeah.
Good point. Kate, please.
Why did you drop the parentheses?
These here?
Yeah.
3 points, 4 points, 5 points for this question. 6. Look, no, I always count up because I just keep thinking of how many mistakes I've seen in the past and how valuable the question is. Right here, you must have parentheses. Right here, you must have parentheses. Because what you had at the beginning was 3 factors being multiplied. So the very next line still has to be 3 factors being multiplied. These are 2 terms being added. If I don't have the parentheses, it's going to look like this is completely separate, which it is not. You'll see problems in the future where this will not become 0. It will become something like 2x, in which case you cannot drop the parentheses. Because it was 0, we lost the extra term, so these 2 things are just multiplying, so I don't need the parentheses any longer. Does that answer your question? Anybody else? Gracie, no?
How did you get x's and g of x?
Oh.
The power series.
So in the rules, you'll notice that there's lots of g of x symbols. Down towards the bottom, there's quite a f symbols. There's an h symbol. Those don't ever match up exactly with whatever problem you're working on. They're just symbols representing something, just whatever. So as you work through the problem, what you think g of x should be will change. So in the very beginning, I think of this as g of x. And I have g of x to a number. So I'm going to use the power rule because I have g of x to a number. Get there? When I get to this spot, actually here, I'm no longer thinking of this as being g. I'm now thinking of this as being f plus g. But not this f. Okay? Just the old f. And that's why I can use the add subtract rule. Because the add subtract rule works when I have f plus g. Did that make any sense? You can shake your head no if it didn't. So, my best guess is that when you see f, you think this is always f. The symbol f is generic. I could have said h or g or k or whatever. It doesn't really matter. The rules, the symbols are not meant to match exactly. The symbols are just representing any expression. So in this rule, this could be any expression at all. In this rule, this could be any kind of expression, any other kind of expression. It doesn't matter. It has nothing to do with this being out. So first thing I do, I think of this as being g squared. So the power rule works because it's g squared. Once I've used the power rule, I forget that. Done. I'm not thinking of g anymore. When I get to here, this could be g to the first power. That would work. You all should put something on your green card. Something for all immigrants. You should put something on your green card. Okay? On the green card, it should say that don't use the power rule if n equals 1. It's not illegal, it just isn't helpful. So don't use the power rule when n equals 1. Oh, please, Carter.
So since the notation for the power rule and the notation for the add subtract rule are always going to be the same, does that mean every time you use the power rule, you'll be able to follow it up with the add subtract rule?
Oh, no, not necessarily. Yeah, that just happened. It's somewhat common, but not always. So, good point. So back to Gracie, look. So from here to here, I am thinking of g as being 3x to the 4th minus 5. But when I get to here, I'm thinking, okay, I don't want to use the power rule, so I have to find a different rule. And what I see is this. If I think of this as being this f, and I think of the 5 as being this g, it fits. Because the add subtract rule, I wrote an example where there are 3 terms being added, but this rule works for 2 or 5, or does that feel better? Better? Okay, please, go ahead.
So on the multiplying constant rule, it says d of a of f, and then it's like equals a. What is the a?
The a is just any multiplying constant.
Okay.
So in this case, the multiplying constant is 3. This could be 6, -2, 8, 5.5, any constant.
Okay.
Does that answer your question?
Yes.
What? Good questions. Anybody else? Okay. Reminder. Write everything I write. It is tedious for a while, but it will become much, much easier little by little. In fact, it doesn't take very long. Point of encouragement. In about a week and a half, 2 weeks, after doing a few assignments, you'll be able to look at this and probably write the purple. That's always written usually. Although it's time we can even start skipping that. And then you'll be able to jump all the way to here. This is my 13th year doing this. You can trust me. It happens every year. Without fail, no one ever struggles. Like if you, the only people who struggle who just are, they just refuse to write what I write. Okay? If you write what I write, and you're not lazy, you just write what I write, it will naturally occur. You won't even have to work at it. You'll just eventually go, oh, I can see it now. I can go straight from here, clear to here. Dead true. And on the AP test, it's legal. You're not writing all these steps because AP requires it. You're writing the steps because I have found if you don't, you get really mixed up, and I will not help you, okay? If you write the steps, it's really easy. Just this will happen. So, questions? Okay, other good news. If this makes sense, there really is nothing left to teach you for this entire unit. We just need to practice for a couple of weeks and then take a test. I'm dead serious.
So we have to have this memorized, the green sheet?
So the other thing that happens very naturally, without you even trying, I'm not kidding. Listen, hey. If you write what I write, it's magic. If you write what I write, like you are diligent, and you don't skip steps, you don't get lazy, most of these formulas will just kind of naturally just get memorized. It happens every year. Everyone says the same thing every year, like, you've got to be kidding. Okay? And then it just happened. Yeah, there's nothing I can do about it. This is a requirement for AP. So, other questions, concerns? Please don't do the following. Do not get lazy and stop writing the DX on the bottom. Okay? Now, the normal way to get your test scores, listen, is in July, you log on, you can look up your test score on a certain date. I do not want you to be that student who logs on, and there's a little note that says, oh, sorry, your test results will arrive in the mail. And they're like, oh, what? And then like 2 days later, you get this package in the mail, like a big envelope. And so who in this room has great self-confidence? Your self-confidence will not be affected by just a little demonstration. Oh, Michaela's awesome. Okay. So you get this envelope in the mail. And you're like, what the heck? You know? And you open up the envelope. You take out, it's your test. It's a copy of your test. I'm not good at doing jokes. I just can't stop smiling. It's a copy of your test. And you look at it, what? And you turn the page, and this is what's on your test. And then you turn the page, and it's like, what the? There's another one. It says, you're an idiot. Sorry about that.
That's okay.
It says you're an idiot.
I literally said
So no, you leave off the DX, they're not gonna score your test. Just put stamps all over it, okay? Not true, but you know. I thought it'd make a good demonstration. Last year he told this little story about using a stamp, and the kids are like, you really have a stamp? I'm like, I have a stamp? And one girl, Emily Downing, she went and bought me a stamp. So, it's kind of fun. Okay, it's a good thing Michaela has great self-confidence.
Yeah, that's a great student.
I got it. Yeah, I might just like put this on my head today.